So this is problem B, the one that we talked about yesterday. So sort of remember that the key idea here was the fact that the solution is really just a solution to a linear Diophantine equation. So it's 11a plus 111b is congruent to, it's just equal to x, right? So x is the input. And so I sort of talked about the high-level solution based on, the healthy UG video that I linked in the description of that video. And so the idea is you want to solve for a, and so you get that a equals. So you take the modulo of both sides, and then you get 11a is congruent to x mod 111. And so you can solve for a just by taking the modular inverse of 11 multiplied by x mod 111, right? And so it turns out that the modular inverse of 11, and you can pre-compute this, right? You can either do it programmatically, but because you know that in every case it's always going to be 11, you could just sort of even look it up on the internet. So this is going to be 101. So a just boils down to 101 times x mod 111. And so now you have a, right? So now that you have a, you can kind of say, okay, is my a small enough, right, such that this because we know that the x is always going to be positive. So we know that the solution has to be positive, right? So we can't have b be this negative number. So we just have to check if x minus 11a is greater than or equal to 0. You can sort of see that in the code here as well, right? So you just multiply 101 times x, the modular inverse here, right? And then you mod by 111, and then you just case on whether or not the difference is going to be greater than or equal to 0.